great day yesterday. Welcome back to Automotive Clinic Summit. Really proud today to have our first speaker, Kenichi Murata from Toyota. He's the Project General Manager and Group Manager for Connected Strategy at Toyota Motor Corporation. And today he's going to give a great talk about experiences of AGL development to Toyota vehicles. So please welcome Kenichi Murata.
Thank you, Dan, for introduction. Today, I would like to explain a little bit about how Toyota was involved in development of AGL and hardware products for ourselves using the AGL-based software. And 2011, Toyota joined the Linux Foundation as a gold membership level. And at the time, the first LS Automotive Development Summit was held in Yokohama, Japan. And we just exchanged the idea how we can go this way. But at the time, many people complained like, automotive world is a very conservative, closed, and you must be very crazy about this. But actually, the many people gathered there and discussed how we can change the world at the time. In 2012, yet another Automotive Linux summit was held in UK, and we had to start something new movement. Then, automotive Great Linux Working Group was set in the Linux Foundation. And many people gathered and we disclosed that why this is important, what is the approach towards the future. And we decided to make the open requirement specification for automotive use cases, especially for IVI products. And also, the important things we decided at the beginning of the starting point of the AGL, we decided we have to take the approach of code first in this. That was the main differentiation portions with other projects in other areas as well. And actually, at the time, the Tizen IVI was already started, so that we picked the Tizen IVI was a kind of a reference platform software at the time of AGL realization. However, we decided choose the reference software platform manually. That was a key point. In 2013, yet another next third Automotive Linux Summit was held in Tokyo. And also in fall, we had the same one in Edinburgh, UK. So we had two Automotive Linux Summits at the time because people were getting more interest of that. And then we showed the home screen concept of the demonstration of Azure-based software. And we started to contribute to the Azure activities. And at the same time, we introduced the Linux-based IVI product in 2013. However, this is not really like fully open to this. We're just getting some of Linux-based operating system kernel portions and carry over most of the portion of the past asset, which is written for the other real-time operating systems. So it's not really like open-based. In 2014, in another Automotive Linux Summit in Tokyo, the steering committee meeting, steering committees in the meeting decided to start the Azure own project. And we gathered lots of requests and requirements or ideas, what kind of things we have to deal with for making it real. And it's funded by the AGL group. In 2015, we finally issued a document which describes about the requirement specification of automotive use cases. And that was so-called AGL requirement specification version 1.0. That was released in the LS 2015. This was, until this moment, we discussed discussed. Nothing happens. Then really, that's so-called open source project. However, this code is fragmented. Some people are trying to modify or add features on Tizen API, but some people still keep it in a separate way. So that's what's happening by the time. So from now, I would like to explain how to involve AGL activity. Of course, we deeply involved to define the specification definitions. And then from 2015, at the same time, in the fall time, we decided to make a code by ourselves. That's the so-called unified code base, or UCB. And we put the demonstration applications on top of that. That was initially very similar to what Tizen API does, but Tizen API includes more than the software components which is necessary for API. So that we eliminate that kind of portions, and then we add more for automotive use cases. And at the time, Intel Renesas Laboratories provide the reference hardware to set up that kind of software environment on top of them. After 2016, we put more effort, like initiating the navigation working groups to define the APIs for navigation software. Navigation software itself will be commercialized version of software, but we would like to keep some consistent interfaces to access or to be accessed from the navigation applications. So that's a kind of a new expert group. And also we provided home screen applications as a sample of how the AGL can be leveraged for the actual production. And we also collaborated working together with other semiconductor companies like NXP or for IMAX, Texas Instruments for Jet Shield, and Qualcomm for Snapdragon. So now almost all the SoC vendors support AGL. And this year, we also expanded the idea of the home screen concept to the HMI framework as a part of the application framework. And Vivo interfaces like a canvas controlling is much more concrete, and now it's expanded. And also, we initiated the discussion about how the reference hardware architecture should be. In the past, each semiconductor companies are really willing to provide the reference hardware of their semiconductor, but if it's not matching with our requirements, or it's not transparent, then we have to deal with many ways to deal with that kind of different types of the hardware architecture. However, if we can set up some level of the common reference hardware architecture, then all upper level of software can run consistently with many different kinds of hardware architecture. That's the point. And we do that kind of things right now. So probably today, or I'm not sure, but today or tomorrow, Goto-san from Master will explain that kind of things. For the future, for the HMI framework should be much more extended with the integration with window managers or some managers as a whole application framework. So it's going to be very much easier to write application instantly on top of it. And we have a plan to show some demo cases in the CS timing. And also Vico interfaces. Today, we made demonstrations for all of you, and I will explain a little bit this about later. And also the hardware reference architecture discussion will be open today, so you can join that kind of thing. So that many semiconductor companies, for the many, not only for the SoC, but also the other interfaces, devices companies can join that kind of discussion later, so that we can offer the consistent reference architecture for writing the software easy. Okay, from now, I'd like to explain a little bit about the product itself. for our view. As I said, the AGL was referencing Titan MRI. And before starting UCB activity, we started to develop the software using the very consistent to this kind of open manner of software development. And then that was introduced in PHP Prime from last year. And based on the specification created in AGL, we wrote this product requirement specification for our tier ones. And as a result, it is implemented in CAM from this year. So I'm very happy to say we deploy the idea and the software of AGL into the market. By the way, the Pulse Prime is based on the Tizen MRI, and that's based on the Intel's hardware and software architecture. I really appreciate that to have innovation of software. And as a lessons from that, it's fully reflected to define the AGL specification. And then AGL software is now implemented in the market with Renesas architecture in CAM. All these are happening. So please welcome Mr. Takagi as a project manager of the product of IBI, of Pulse PHP, which tremendously contributed to AGL discussions.
Good morning, ladies and gentlemen. My name is Kenichi Murata from Tensor Corporation, and product manager for this IBI product. This product development started from 2013, and mainly for platform layer, collaborated with Intel, and in that time frame, to show the various contents on one screen was very specification or requirement for automotive products. And so in these fields, Tensor integrated our knowledge in the product and contributed to AGL, mainly for Wayland extension and sound manager and DLT. For platform layer development, we 100% concentrated our effort to this open source activity, and by this activity, we were able to get a very stable platform in early development stage. That was a merit for us. I mean, for application development. Application development used over 20 team application development team used this platform, and to get the stable platform is very important. That was a good point for us. So as a result, we were able to concentrate our effort to get more cool HMI or valuable applications. So finally, of course, this is the first step of our open source activity development, but we'd like to continuously contribute to open source activity and want to go to the next step. Thank you very much.
Thank you very much. And also, today I'd like to welcome Mizuyama-san from Panasonic. Please have me a comment.
Thank you, Murata-san. I'm Masashige Mizuyama, CTO of Automotive Business at Panasonic. Panasonic is so much proud of being a part of Toyota development team of this amazing vehicle, Camry. And without AGL, we could never realize this feature-rich, huge scale eyewear systems with high quality user experience. I'm confident that is a great achievement of the team. But at the same time, I believe, strongly believe, this is a monumental achievement of all AGL developer community.
Yeah.
So, ladies and gentlemen, let's celebrate the first ever launch of AGL product. And we will continue to contribute AGL. Thank you very much.
And also, as both of you mentioned, we together, as OEM and Tier 1s, we are really continue to contribute back to Asia from the lessons we learned from the development. By the way, the software development is a technology. But if we think about how to deploy that kind of software technology into a product, we have to think about more than that. Like for the patent risk, some Linux users have been involved in the patent infringement cases. And if we count number of the patents in Linux portions, about 300,000 patents are already found. So even we use the open source, we cannot avoid litigations. However, it will be very difficult to grasp all the operating system related to patents in the source code because it's huge. So we joined OIN as an NPO organization to decrease the patent risk. The OIN participants is now exceeded more than 2,000 companies, from the startups to the very large scale companies. And Toyota was the 8th board member company of OIN now. And then also many other automaker OEMs are joining them as member of OIN. And they hold, all the members hold the 2.8 millions of patents. So all members which participating in OIN agree to cross-license other members, so that you can you don't have to check the patents which is submitted to those other member companies. But that's only limited to apply to the OIN Linux system definitions areas used for Linux. So the question is, what is defined in the OIN Linux system definitions? Of course, the kernel or common base packages are covered, and software engineering tools like Perl or Python or PHP, that kind of things covered. And other things is enterprise engineering tools or networking, security, or web services related to software components are covered. However, there are missing parts, AGL, IoT, and AGL is a matter of us item. So, as a board member of OIN, we would like to really help AGL activity to cover the area of AGL into this definition. And it's still, it's just started to discuss this kind of things. And for the safety of AGL, it's important to increase the participants of OIN, and we really like to continue to reduce the OIN system Linux definition to fit the situation of AGL development. And to discuss open source license issues with AGL community and Land Foundation, we really would like to start that kind of discussions among AGL community to decrease the compliance risk of each developer. So, Endo-san from Toyota Motor Corporation is leading that kind of activities, so please join us. I'd like to explain a little bit about our demonstration today. On the downstairs, you can see the demonstration using vehicle information interfaces, which is not really directly related to the product itself, so as of today. However, it's using the latest version of AGL UCB to show it is working with real vehicle and the real candidates. So you can drop it down to the stairs, down to the first street, and then get out the building from the back door so that you can see the Lexus RX, and which shows some of those kinds of the applications running with our vehicle. You can show the same slides on their side. And the location is like this, and the demonstration timing is today and tomorrow. Actually, yesterday we did that as well, during the break time. So, and as today, I was just introduced as Camry is the first vehicle in North America to embed AGL-based software, but it will be delivered to the rest of the world as well, the rest of the models as well, from our tier 1 suppliers like ICAW, Fujitsu 10, Pioneer, Harman. So we really would like to collaborate with this kind of things. And also you can see the demonstration just in front of the escalators on the fourth floor. There is an AGL demonstration. It's a really collaborative demonstration. Engineers from Fujitsu 10, engineers from Panasonic, Denso, ICAW, and also social companies like MTT, MC, or many companies are gathering to build up a single demonstration. It's quite unique activity, I think, and that makes stronger of us. Thank you very much.
Thank you, Murata-san. That was great. And thank you, Denso Panasonic, also for participating. Okay, our next speaker is Dominique Adfol from Intel Open Source Technology Center. He's a senior software architect. Dominique has been involved in open source for a long time. Many of you probably know him. He's been involved in PAS90i and most recently one of the big contributors to AGL. His talk today will be Software on Wheels and the New Paradigm. So please welcome Dominique Adfol. Thank you.
Hello, yes, I'm working from Intel, and Intel is widely involved in open source. Most of you must know that from the kernel activities and all of the other activity we have, and we're also involved in AGL. What I want to talk about today is something that we have seen happening in other industries before, where software is actually taking the key position into the value of the product as well as in the cost of the creation of those products. So in reality, very, very quickly, cars are going to become software on wheels, with all the advantages of software and all the disadvantages of software. One thing that is to be remembered is that software, even if it's quite often created a little bit like a craft rather than an industry, we have to try to think it as an industry. So, what is really changing? First of all, the way people are buying cars is changing seriously. The value in the car is moving. It's not anymore a practical tool to go from A to B, but it's something where emotion becomes a very key point in the purchasing decision, far more than actually the capability of the car to transport, because more or less every cars today are capable to go from A to B in a practical, reliable way. With that, a lot of features are actually software-based. When you go to emotion, to the pleasure, and later on to driving helps and even self-driving, all of these features are going to be actually based on software. Which means that software is going to become critical. And it's going to be critical very quickly, and it's going to go from bad to worse in one way. We start with connected car, with complex audio video, but we want to add remote maintenance, real-time navigations. We also want to connect the user, not only the car. And we want to do that to have personalized streaming music. That's one of the biggest demands for drivers today. Social network interactions and payment, which obviously create a complete new level of complexity in the software. And we are moving forward to driving help, and on the longer run, even self-driving. So that becoming critical, it will soon be actually as important the way you develop the software in your cars, and it's actually you create an engine. And so it's going to become one of the high-value components. And some prediction is that the rising cost in the creation of the car is already 35%. I don't have these numbers, I don't work for car manufacturers, but I actually found them in some studies. And I'm not surprised, but it's going to increase. And I remember in the industry of telecom where we have seen the software actually starting to cost more than the hardware. And people would not believe it would happen, and it happened significantly quicker we had so. And the specificity side of the software is that while the hardware is a one-off, you buy a hardware, you put it somewhere and it works, the software is never finished. It's an open complexity. And the maintenance of the software in industry where you have to maintain software, it's actually typically from 70 to 80% of the total cost of the software. And unfortunately, or fortunately for us, like people who do software, car will have to maintain software. And you will have to maintain them because you're going to connect the car, and as soon as you connect the car, you're going to have cybersecurity problems. And that will make mandatory and maintenance. And I know a lot of the industry just still believe that cybersecurity is not a major issue for cars and is going to happen. I don't want to be involved in AGL project and having an AGL car being crypto-locked. But if you look at what happened 10 days ago, Nissan and Renault factory were crypto-locked. No, and someone will have one day a car that will be also done. So, what I wanted to tell you today is that this has happened in other industry. I was working in the telecom industry for quite a longer time than in the automotive one, and typically around 2000 we did a big move to a software-driven industry. And today we are even further in the telecom industry where fundamentally we have standard hardware and we actually use standard software module and we use virtualizations. I was digging in the history and I found out actually a paper that I published with my brother in a research paper from British Telecom in 2003, which was called open source software in telco, a gentle tsunami. What we found out in the telecom industry is when the software became the major complexity in creating product, is that we had to change the way we were thinking. We had to change the way we were even recruiting our engineers. We had to change the way we were managing them. Now, the car industry will have to go through an equivalent revolution. It will be different because the world never repeats itself, but there are a lot of things that can be learned from those experiences, and I really encourage all of you to start to look at what has happened in different industries. The second industry that actually moved to that world has been the consumer electronics. And today, when I look at the complexity of software, I believe the TV business is by far the closest business to automotive from a software creation point of view. And what was found out in the TV business is that the cost of creation of software was becoming so big that actually people had to start to use more sophisticated hardware to help them to do it. So there's still a lot of people who believe that You know, we need to have the smallest hardware possible because that's the lowest cost, and the buyer is the guy who decides everything, and if he can squeeze 20 cents out of the product, he will do it. And what we found out in the consumer electronic is that when we were squeezing 20 cents out of the hardware, we were actually increasing the cost of the product by 50 cents because of the side effect of the software. So this is a balance which will have to be looked at very quickly in the car industry. And that means that the way you are going to have to consider the cost of creation of a product will have to change. Which will drive to my last point in what I expect is going to happen in this world. You're going to have to need to take ownership of every key asset. You know, in every industry, what is key has to be owned by the one who is selling. You would not expect to go and buy a car and not have the engine in it, because it's a key asset. It's going to be the same with software. You know, the software will become so critical that it will have to be owned by the people. And own doesn't mean that they do everything, but you know, they will have to own the entire responsibility and the entire integration of it. And we start to see big changes in that world. And I just took two examples. One is what was announced by the Renault Group last week, where Renault has actually acquired a team of 420 software engineers specialized in embedded. You know, that's quite a big move. And even look, they're not the first one. Actually, BMW, Daimler, and Audi, Volkswagen did the same things with here when they bought the car, the chart manufacturer, the map manufacturer here. And I know that BMW bought an entire team actually from Nokia in Ulm in Germany as well a few years ago. So the control of the software, the control of the design of the software, and the responsibility of the integration will have to come as part of selling the car. And that is going to change what we see today. So that's what I wanted to pass as a message. Obviously, as Intel, we are happy to help and support you. We are there for that, and I'm sure that other colleagues are doing the same. But I would encourage you to start to look at that concept, and if you want to have chit-chat on what happened in other industry, you know, we'll be welcome to be there and here for the next 2 days, and so we have plenty of time to talk. With this, I wish you a nice day.
Thank you, Dominique. Thank you. Okay, so our next session will be a panel discussion. We will be discussing how shared development will drive the industry forward. So I'd like to welcome, first of all, Keio Munakata from Renesas. He's a senior director at Renesas. Many of you will know him. He's been a long-time open source supporter. He's also on the board of directors of Linux Foundation. I'd also like to welcome back Kenichi Murata, Group Manager of Connected and Strategy Planning at Toyota Motor Corporation. And also Hiromi Wada, Co-Director of AV and ICT Development Center at Panasonic. So please welcome our panelists. Okay, thank you for joining us. Thank you. Let's kick off the session with a general question about AGL. How is your company investing in AGL and open source in general, and what impact does it have on your business? Maybe Wada-san, start.
Hi. First of all, I'd like to correct my organization.
Okay.